Software fails. No matter how carefully it's built, something will eventually break. And when that happens, you need to figure out why, fast. That's where observability comes in. It's the ability to understand what's happening inside a system just by looking at its output. In the past, debugging was a little simpler. Older systems had a limited set of failure modes. So when something broke, you usually had a good idea what went wrong. But as software evolved into complex, distributed, cloud-native microservices, the number of possible failures skyrocketed. Suddenly, tracking down problems wasn't so easy anymore. Traditional monitoring helped for a while, giving teams insight into system health through predefined metrics and alerts. But it had a major limitation. It could only track problems you already knew to look for. And that's the problem. Modern systems break in ways we don't always anticipate. Sometimes we don't even know what we don't know. And if you can't track an issue, you can't fix it. That's why observability has become so critical. It helps teams move beyond just monitoring known problems and instead detect, investigate, and resolve unknown failures faster. How do you build observability into a system? The foundation of observability comes down to three main pillars: metrics, logs, and tracing. Metrics track system health over time. They give you a high-level view of things like CPU usage, requested latency, and error rates. But while metrics are great for spotting anomalies, they won't tell you why something is happening. That's where logs come in. Logs provide detailed records of what happened at specific moments. If a metric shows a spike in error rates, logs help developers drill down and see what triggered the issue. The challenge? Logging everything generates a massive amount of data, making it difficult to store and analyze efficiently. Then there's tracing. Tracing follows the flow of requests through a system, showing how different services interact. It's particularly useful in microservices architecture, where a single user request might pass through dozens of services before completing. If something goes wrong, tracing helps pinpoint exactly where the failure occurred. Modern observability tools also focus on user experience and business impact, not just technical metrics. For example, user-centric analysis or end-user monitoring are supported by many observability tools. Challenges of observability. While observability provides deeper insights, it comes with challenges. Collecting, storing, and analyzing massive amounts of logs and traces can quickly become overwhelming and expensive. Some companies sample logs selectively, only storing the most important data. Others invest in high-performance observability platforms to manage their data efficiently. AI-driven anomaly detection and intelligence alerting are the new approaches that many tools are trying to integrate. The right approach depends on the scale and complexity of your system. Every company implements observability differently. Some track hundreds of metrics, while others focus on just a few key indicators. Some keep detailed logs indefinitely, while others aggressively downsample them to reduce costs. Integrating observability tools in the CI/CD pipelines can help users see the broader impact. The important thing is having a strategy that works for your team and your system. At the end of the day, observability isn't just a buzzword. It's essential for modern software reliability. The teams that prioritize it from the start will be the ones who can recover quickly when, not if, something goes wrong. If this helped you understand why observability matters, hit the like button and subscribe for more insights on building resilient systems. See you in the next one.